All right, let's get right into it. We are so far beyond simple chatbots now. The real ambition, the new frontier for AI agents, is to have them tackle these huge, complex jobs, things that might take a human days or even weeks to complete. But this amazing ambition has slammed right into a massive bottleneck. And it's not about the model's intelligence, it's about its memory. Today, we're going to break down this AI context crisis and talk about the new field of engineering that's here to solve it. So just imagine saying this to an AI agent: go analyze the last week of financial market data, check it against all the news reports, figure out the key trends, and then write me a full-on report. The source material calls this a long horizon task. And it is. It involves hundreds of steps, tons of data, and this long, fragile chain of reasoning. This is exactly what we want AI to do for us, but, well, it creates a really fundamental problem. And yeah, that's the heart of the problem, right? As an agent works on a huge task like that, it's history. Every thought it has, every tool it uses, every single piece of data it looks at, it just grows and grows and grows. This running history is what we call its context. And it explodes almost instantly from a simple to-do list into this totally unmanageable, million-page-long mess. Now, you might be thinking, hey, the solution is easy. Just give the AI a bigger memory, a larger context window. And for a little while, that was the main strategy in the industry. But as we're about to see, just throwing more tokens at the problem doesn't just fail to solve it. It actually creates a whole new set of even worse issues. So here's the thing. This whole just append everything to the list approach completely falls apart under what is essentially a three-way pressure. First, your cost and your latency just spiral out of control. Every single token you add makes the very next step slower and more expensive. Second, the model itself gets confused. There's this phenomenon called lost in the middle, where the important instructions get totally buried under a mountain of old, irrelevant data. And finally, you just hit a hard physical wall. Real-world tasks will always generate more data than even the biggest context window can possibly hold. It's just not a sustainable strategy. So, to get out of this trap, we need a completely new way of thinking, a new blueprint. This is where we make the leap from just writing clever prompts to this new discipline called context engineering. And the central metaphor here is really powerful. We need to stop treating an AI's memory like a messy, endless transcript and start treating it like a compiled program. And this slide just lays out that huge shift perfectly. On the left, you've got the old way, this one giant, noisy, super expensive text file. But on the right, the new way is what's called a compiled view. It's an intelligent system that basically acts like a compiler. It takes all the information that's available, and it builds this small, clean, highly relevant package of instructions just for the model and just for this specific step. And that brings us to the formal definition. Context engineering really just means we have to stop thinking of context as, well, just a long string of text. Instead, we have to treat it like a critical piece of our infrastructure. It's a first-class system that needs its own architecture, its own rules, its own lifecycle, just like you'd think about a database or a compute cluster. This quote is the core thesis from Google's Agent Development Kit, or ADK. It says it all. The context that the AI actually sees isn't the raw data. It's a carefully compiled snapshot of a much larger, much richer system of information. This single idea, it changes everything about how we build these agents. So what does this compiler actually look like in practice? Let's peel back the layers and look inside the architecture of Google's ADK to really understand the mechanics of how this works. Okay, so the ADK's design is built on three really important pillars. First, there's structure, a tiered model that separates how you store information from what the model actually gets to see. Second is relevance, having smart controls that decide what information is critical at this exact moment. And third, having specific rules for managing context when you have multiple agents all trying to work together. Let's break down that first pillar, structure. ADK organizes all its information into four distinct layers. So you've got the working context, that's the final compiled prompt. It's small, efficient, and it gets thrown away after each use. Then there's the session, which is the complete structure of log of everything that's happened. Think of memory as the agent's long-term knowledge, like remembering user preferences. And finally, artifacts, which are for huge files that get referenced by name instead of being wastefully pasted in.
Now, this whole structure is designed to prevent a super common and really bad mistake, which the source material calls context dumping. This is what happens when you just paste a massive file, like a 5 MB CSV, directly into the conversation. It becomes this permanent tax, bloating every single future step, slowing everything down, and just totally confusing the model.
So the solution, using that artifacts tier we just talked about, is something called the handle pattern. Instead of dumping the whole file in, you just give the agent a tiny, lightweight reference, a handle, like the file name report.csv. The actual massive file lives somewhere else and is only loaded into the working context for the brief moment it's actually needed. This keeps the whole conversation lean, fast, and efficient.
Okay, so if context is a big problem for one agent, it's an even bigger problem when you have a whole team of agents. When one agent hands off a task to another, the naive way to do it is to just pass along its entire history. But this leads to what's called a context explosion, where the memory requirements just grow exponentially, and the poor subagents get totally lost in irrelevant details from what other agents were doing. ADK solves this with two really smart patterns. You can treat a specialized agent just like a simple tool. It gets one command, returns a result, and sees zero history. That's it. Or, when you do need to do a full handoff, you explicitly scope the context, creating this minimal, clean version of the history that's only relevant to the sub-agent-specific job. No more information overload. So this is all great from an architectural point of view, but how does a developer actually use it? Well, ADK provides a whole toolkit of specialized objects that give your code exactly the right level of access and capability for any given task. And this right here is a fantastic overview for anyone who actually builds these systems. An agent's core logic gets the super powerful invocation context with full access to everything. Then you have callbacks, which kind of inspect the process. They get a more limited callback context that can look at and modify state. And then tools get a tool context, which has all that plus special powers like searching memory or handling authentication. It's all about giving the right permissions to the right part of the system. Okay, let's zoom out for the big picture here as we wrap up. This whole move to context engineering, it represents a truly fundamental shift in how we need to think about building AI applications. The era of just trying to trick a model with clever prompt gymnastics is coming to an end. To build powerful, reliable, and scalable agents, we have to start thinking like true systems engineers. We need to care about architecture, observability, and efficiency, not just manipulating strings of text. And this final quote from the source just drives the point home perfectly. For agents to take on these truly ambitious, long-horizon tasks, managing their context has to be treated as a core architectural challenge, something just as important as choosing your database or your cloud provider. Honestly, this architectural leap forward is incredibly exciting. It unlocks the potential for agents that can reason, plan, and execute tasks over long periods of time without getting lost or, breaking the bank, which really leaves us all with the one big question. Now that we can actually build AI that remembers and learns intelligently, what new, world-changing tasks will we finally ask it to do?